In this section, we're going to look at the built-in data structures in Python, which are extremely important when building real applications. First, we're going to look at lists, and then we'll look at tuples, sets, and dictionaries. So earlier you have seen that we can use square brackets to define a list or a sequence of objects. In between these brackets, we can have objects of any type. So we can have a list of strings like this, and then assign it to a variable like letters. We can also have a list of numbers, booleans, or even a list of lists. Let me show you. So here we have a list. Each item in this list will be a list itself. So here's the first item, which is a list of 2 items. Now let's add another item to our main or parent list. This item is also a list with 2 items. So now we have a matrix, which is a 2-dimensional list. Now let me show you some cool tricks. Let's say you want to have a list of 100 zeros. You don't want to manually create that like this. That's very ugly. Let me show you a better way. So we define a list of 1 item, 1 0, and then we can multiply it by 100. And the result will be this. Let me show you. Print zeros. Here it is. There you go. So using a star or an asterisk, we can repeat the items in a list. Now, similarly, we can use a plus to concatenate multiple lists. Let me show you. So first, I'm going to change this to 5. Now, let's define a variable combined, which is our zeros list plus letters. Let's see what happens. Print combined. You know it. So we have 5 zeros followed by A, B, C. As you can see in Python, every object in a list can be of a different type. So they don't have to be exactly the same type. We can combine a list of numbers with strings and booleans or even lists. Now, let's say you want to have a list of numbers like 0, 1, 2, 3, all the way up to 20. You don't want to type all of these by hand. There is a better way. So we have this list function. As you can see, this function takes an iterable. So we can pass any iterable here and convert it to a list. Earlier you learned about the range function. This function returns a range object which is iterable, which means we can iterate or loop over it. So here we can call this function and pass 20. And with this, we can create a list of numbers from 0 to 20. Let me show you. So let's store it in numbers and then print it on the terminal. There you go. So 0 up to 20. But note that 20 itself is not included. As another example, let's call the list function and pass a string. Earlier, I told you that strings are also iterable. We can loop over them. So we can pass them to the list function and see what we get. Let's print chars on the terminal. So you can see each character in our original string is an item in this list. So these are a few different ways to create a list in Python. Now that we have a list, we can get the number of items in that list using the len function. So here we can print the len or length of chars. Let's take a look. So we have 11 items in this list. Over the next few lectures, we'll look at various operations around lists. So here we have a list of 4 items. We can use square brackets to access individual items in this list. So let's print letters of 0. This will return the first item in this list. So when we run this program, we'll get A. Now, similar to strings, if we pass a negative index here, like -1, this will return the first item from the end of the list. So when you run this, we'll get D. Using square brackets, we can also modify items in the list. So let's change the first item to a capital A and then print the entire list. There you go. So this is the basic of accessing individual elements in a list. Now, earlier in the course, you learned that we can use 2 indexes to slice a string. We have the exact same concept here. So we add square brackets, first index, colon, second index. And this will return a new list with the first 3 items in our original list. So if we print our original list, you can see that it's not changed. Now, just like strings, if you don't specify the first argument, 0 will be assumed by default. So as you can see, these two expressions produce the exact same result. Similarly, if you don't include the end index, by default, the length of the list will be used here. So this expression will return a new list with all the items in the original list. And similarly, we can also exclude the start index here. And with this syntax, we can get a copy of our original list. There you go. Now, when slicing a string, we can also pass a step. And this is useful in situations where you want to return every second or every third element in the original list. So now when we run this code, we'll get A and C. So B will be skipped. Let me show you using a better example. So I'm going to delete everything here. Create a new list called numbers. Here we're going to use the list function and pass range of 20. Let's print our list. So we get numbers 0 to 19. Okay. Now let's see what happens when we add square brackets here with 2 colons and 2. This will return every other element in the original list. Take a look. So we get all the even numbers, 0, 2, 4, and so on. That's pretty cool, isn't it? Here's another cool thing you can do here. Let's change the step to -1. As you can see, this will return all the items in the original list, but in reverse order. So these are some useful things you can do with lists. Next, we'll look at unpacking lists. There are times that you may want to get individual items in a list and assign them to different variables. Here's an example. We can define a variable like first and set it to numbers of 0. Similarly, we can define second, set it to numbers of 1, and third, set it to numbers of 2. Perhaps you're going to use these variables in a few complex expressions in your code. Now, there is a cleaner and more elegant way to achieve the same result, and that is what we call list unpacking. So we can unpack this list into multiple variables. Let me show you how that works. So we define our variables like first, second, and third, and then set them to our list. What we have on line 2 is exactly identical to what we have on lines 4 to 6. This is what we call list unpacking. Now, what is important here is that the number of variables that we have on the left side of the assignment operator should be equal to the number of items we have in the list. So if we exclude third here and run this program, we will get an error. Value error, too many values to unpack. So there are too many items in this list, and we cannot unpack it into enough variables. Now, what if in this list we have so many items, but we only care about the first 2? We don't want to define so many variables on the left side of the assignment operator. Well, we can get the first and second, and then pack the rest inside of a separate list called other. With this syntax, we'll get the first and second items, and everything else will be stored in a separate list called other. Let me show you. So let's print first, and let's also print other. Now, we don't need these few lines here. Let's run this code. So first is 1, and other is a list of all the items after the second item. That is the list I'm talking about. So in this example, we have both unpacking and packing. First, we try to unpack this numbers list into the variables on the left side of the assignment operator. And then because we have used an asterisk here, we're basically packing all the other items into a separate list. Now, to refresh your memory, earlier we used this syntax when defining a function with a variable number of arguments. Remember? We had a function like this, multiply, with a parameter called asterisk numbers. And then we could call this multiply with arbitrary number of arguments. So when we prefix a parameter with an asterisk, Python will get all these arbitrary arguments and pack them into a list. This is exactly what is happening on line 2. Now let me delete this other stuff. Now let's change this example a little bit. What if we care only about the first and the last item? Well, we can put other in between, so we get the first, other, and then the last item. So let's change the last item to 9, and then print first, last, and other. This is what we get. So first is 1, last is 9, and the rest is here. So this is all about list unpacking. In this lecture, I'm going to show you how to loop over lists. So here we have a list of 3 items. We can use our for loops to loop over this list. So for letter in letters, colon, and then we print each letter. Save the changes and run the code, we get A, B, C. Now, what if we want to get the index of each item as well? Well, we have a built-in function called enumerate. We call it here, and this will return an enumerate object, which is iterable. In each iteration, this enumerate object will give us a tuple. Let me show you. So now when we run this code, look, in each iteration, we're getting a tuple. So a tuple, as I told you before, is like a list, but it's read-only. We cannot add new items to it. So in each iteration, we're getting a tuple of 2 items. The first item in this tuple is the index, and the second item is the item at that index. So now to get the index, we can use square brackets to access the first item in this tuple. So if we print letter of 0, we will get the indexes, and right next to that, we can add letter of 1. So we will see the item at a given index. But this syntax is a little bit ugly. In the last lecture, you learned about list unpacking. So if we have a list with 2 items, 0 and A, we can unpack it into 2 variables like this: index, comma, letter equals items. So here we are unpacking the items list. Now, what if we change square brackets to parentheses? Now we have a tuple, and we can still unpack this tuple. So you saw that this enumerate function returns an enumerate object which is iterable. In each iteration, this enumerate object will return a tuple that looks like this. So we can unpack it right here. So we add another variable, index. Now with this, we no longer have to use square brackets, and we can simply print index and letter. Let's run this code. There you go. So now we don't need this anymore. So to recap, you can use for loops to iterate over lists. If you also need the index, you should call the enumerate function. This will return an enumerate object, which is iterable. In each iteration, it will return a tuple, and you can unpack that tuple right here. In this lecture, I'm going to show you how to add new items to a list or remove existing items. So for adding items, you have 2 options depending on where you want to add this new item. If you want to add an item at the end of the list, you should use the append method. So earlier you learned that everything in Python is an object, so you can use the dot notation to access individual functions, or more accurately methods, in that object. So when a function is part of an object, we refer to that function as a method. So here are all the methods available on list objects. We use the append method to add something at the end of this list. Let's print our letters, and we will get A, B, C, D. Beautiful. Now, if you want to add an item at a specific position, you should use the insert method. So letters that insert, we can add something at the beginning of the list. So index 0, let's add a hyphen, and then print the result. So this is what we get. Now for removing objects, again, you have a few different options. If you want to remove the item at the end of the list, you should use the pop method. So here we call letters.pop. This will remove the letter D at the end of our list. So now let's print our letters. As you can see, D is gone. You can also pass an index here to remove the item at the given index. So if we pass 0, instead of D, this hyphen will be removed. Let's take a look. We run this. So the hyphen is gone and we get ABCD. Beautiful. Now there are times that you want to remove an object, but you don't know its index. If that's the case, you can use the remove method. So letters.remove. Here we can remove B, and this will remove the first occurrence of the letter B. So if you have multiple B's, only the first one will be removed. If you want to remove all B's in this list, you will have to loop over this list and remove each B individually. Now let's run this code one more time. So you can see B is gone. We have another way to remove an item from a list, and that is using the del or delete statement. So here we can delete an item by its index. We can also delete a range of items. So this is the difference between the delete statement and the pop method. The pop method will remove only one item by index, whereas with the delete statement, we can remove a range of items. And finally, if you want to remove all the objects in the list, you should use the clear method. Next, we'll look at finding objects in a list. There are times that you want to find the index of a given object in a list. So let's say we want to find the index of letter A in our letters list. We call letters.index and pass A. Let's print the result. So this will return 0. What if you try to get the index of an object that doesn't exist here, like D? We get a value error. D is not in the list. This behavior is different from a lot of programming languages out there. C-based languages return -1 if you try to get the index of an object that doesn't exist in the list. But in Python, we get an error. So to prevent this error from happening, first you should check to see if the given object exists in the list. And for that, we use the in operator. So if D is in letters, then we will print its index. So now we run the program and we don't get any errors. We also have another method that you might find useful in certain situations, and that is count. So letters.count. This will return the number of occurrences of the given item in this list. So when we print the result, we'll get 0. Next, we're going to look at sorting lists. Here we have this list with a bunch of numbers that are not in any particular order. To sort this list, we call numbers.sort. Now let's print it. And you can see our numbers are sorted in ascending order. What if you want to sort these items in descending order? Well, this sort method takes 2 parameters, key, which we'll look at later, and reverse, which we can use to change the sort order. So here we can use a keyword argument to set a value for the reverse parameter. We set this to true, and with this you can see our numbers are sorted in descending order. So this is the basic of sorting lists. However, in addition to the sort method, we have a built-in function called sorted. As you can see, this function takes an iterable, so we can pass any iterables here and it will sort it for us. So we can pass our numbers list, and this will return a new list that is sorted. So unlike the sort method, this will not modify the original list. It will return a new sorted list. So let me comment out this line and print the result of calling this function. Now let's run this program. You can see here is our new list that is sorted, and below that we have our original list that is not sorted. Also, similar to the sort method, if you want to change the sort order, you can simply set the reverse argument to true. Let's run it one more time. And here's the result. Beautiful. So, sorting numbers and strings is pretty easy, but what if you're dealing with a list of complex objects? For example, what if we have a list of tuples? Let me show you. So I'm going to delete everything here. Let's imagine we are building an application for processing orders, and we have this list of order items. Every item in this list is a tuple with two items. The product name, followed by the price. So here's the first item. Now let's add another item with a different price. And finally, the third item. What happens if we try to sort this list? Let's take a look. So items.sort, and then we print the items. So nothing is changed here because Python doesn't know how to sort this list. In situations like this, we need to define a function that Python will use for sorting lists. Let me show you. So here I'm going to define a function. Let's call it sort underline item. This function should take an item like this tuple. There you go. And it should return a value that will be used for sorting. In this example, let's imagine we want to sort these items based on their price. So if each item is a tuple, we can get the price using square brackets of 1. So we'll return item of 1. So all this function does is that it takes an item and it returns its price. Now Python is dealing with a list of numbers and it can easily sort that list. Now finally, we need to pass this function when sorting our list of items. So once again, look at the sort method. The first parameter is key. And this is where we need to pass our sorting function. So we pass sort underline item. But note that I'm not calling this function. I'm simply passing a reference to this function. When Python attempts to sort this list, the list of items, it gets each item and it will pass each item to our sort function. Okay? So let's run this program and see what happens. We get a type error. Sort takes no positional arguments, which basically means here we can only use keyword arguments. So we need to specify our argument that is key. We set it to sort item. Now let's run this program one more time. Okay, look, our list of items is sorted by the price of each item. However, the way we have implemented this sort function is a little bit ugly. There is a better way, and that's what I'm going to show you next. If you have any experience with other programming languages, you've probably heard of the term lambda expression or lambda function. It's basically a simple one-line anonymous function that we can pass to other functions. So here on line 12, we're passing a reference to our sort underline item function. We can improve this code and make it cleaner by using a lambda expression or an anonymous function. So we don't have to define this function first and then pass it here. So we remove this and add lambda. With this, we're telling Python that we're defining a lambda or anonymous function. The syntax for writing a lambda function is like this. We add parameters, colon, expression. So using this syntax, we can rewrite this function. How many parameters do we have here? Only one. So we add that here, item. Then after the colon, we should add an expression. What are we returning in our sort underline item function? We are returning item of 1. So we simply add that here, item of 1. Now you can see with this syntax, we don't need to use def for defining a function. We don't need to give our function a name. We don't need these parentheses here, and we don't need the return statement. So this is a shorter and cleaner way to define a function that we're going to use only once as an argument to another function. Now, let's delete these two lines, run our program again. We'll get the exact same result. Our items are sorted by their price. Over the next two lectures, I'm going to show you more examples of using lambdas in your programs. So here we have this list of items. Let's imagine we want to transform this list into a different shape. So currently, each item in this list is a tuple of 2 items. Let's say we're only interested in the price of these items. So we want to transform this list into a list of numbers, that is the list of prices. Here's a basic way to do this. We can define an empty list, then iterate over our list of items. So for item in items, we call prices dot append item of 1, which returns the price of each item. Now let's print the prices. So we get a list of numbers. With this code, we have transformed or mapped our original list into a different list, okay? But there is a better and more elegant way to achieve the same result. Instead of this loop, we can use the map function. So we call the built-in map function. As you can see, this function takes 2 parameters, a function and 1 or more iterables. So as the first argument, we can pass a lambda function, and as the second argument, we can pass our list of items. This map function will apply our lambda function on each item in this list. Let me show you what I mean. So we pass a lambda. This lambda is a function that will transform each item in our original list. So the parameter to this function is item, and here we simply want to return the price of that item. So item of 1. Now, as the second argument to the map function, we need to pass our items list. So this map function will iterate over this iterable, and it will call this lambda function on each item of this iterable. Now let's see what this function returns. So temporarily, I'm going to assign this to a variable called x. Let's print x, and also we don't need these 3 lines because we can achieve the same result using the map function. So delete. Now let's run this program. So this map function returns a map object, which is another iterable. So we can easily iterate over it. For item in x, we'll print item. There you go. So we get the prices. Alternatively, we can convert this map object into a list object. So we can use our list function. Earlier you learned that you can pass any iterables to this list function to create a new list. So we pass that here, and now we can rename x to prices and simply print prices. We don't need this loop here. Let's run the program so we get a list of 3 numbers. So this is how the map function works. It takes a lambda function and applies it on every item of this iterable. Here's another scenario for using a lambda function. So we have our list of items. Let's say we want to filter this list and only get the items with price greater than or equal to $10. Again, one basic way is to define an empty list, like filtered. Then we iterate over our list of items. For each item, we get the price. If it matches our criteria, we'll add it to this list. But that's pretty basic. A better approach is to use the built-in filter function. Look at the parameters. This function, just like the map function, takes 2 parameters, a function and an iterable. So it will apply this function on each item of this iterable. If the item matches some criteria, it will return it. So let's see how we can use this function. As the first argument, we're going to pass a lambda function. This function takes an item and returns a Boolean value that determines if this item matches a criteria or not. In this case, we want to get the price of each item and see if it's greater than or equal to $10. So the result of this expression is a Boolean value. If it's true, this item will be returned. Now, as the second argument to the filter function, we pass our items list. Let's temporarily store the result in a variable called x and print it. So we get a filter object. A filter object, just like a map object, is iterable, so we can loop over it, and we can also convert it to a list right away. So let's call list. Now we get a filtered list that we can print on the terminal. So as you can see, we only have product 1 and 3 because their prices are greater than $10. So here's the usage of map and filter functions that you just learned about. These two functions are pretty useful in Python, and they're often used by developers who come from a functional programming background. So the concept of mapping and filtering lists is very natural to them. But in Python, we have another feature for achieving the same result. And as far as I know, we don't have this feature in other programming languages. That is called comprehension. So let me show you how that works. Here's the basic syntax. We add our square brackets for defining a list. And here we'll write a comprehension expression like this. Expression for item in items. Well, this part is very familiar to you, right? It's like a for loop. So we are iterating over an iterable and then applying this expression on each item. In this example, if you want to get the price of each item, we can write an expression like this, item of 1. So this is what we call a list comprehension, and it produces the exact same result as what we have on line 7. So let's store the result in prices. As you can see, this code is shorter and cleaner. We don't have all these parentheses and colon. In my opinion, what we have on line 7 is a little bit ugly and noisy. Now, some developers might disagree with me, but generally speaking, in the Python community, the preferred way to map and filter lists is to use list comprehensions. But I wanted to include the map and filter functions in this course because as you look at the code written by others, you'll probably come across instances of using the map and filter functions. So I wanted to make sure that you really understand how they work. But as a best practice, my recommendation to you is to use list comprehensions because they're cleaner and also more performant. So this is how we can use a list comprehension to map a list into a different kind of list. Now, as part of this mapping, we can also filter items. So if I want to rewrite what we have on line 10, using a list comprehension, that would look like this. Filtered, we set it to square brackets. So we're defining a new list. No need to call the list function. In between the brackets, we'll write an expression. So here's the syntax. Expression for item in items. Now, what is the expression here? Well, in this case, we don't want to map the list of items to list of prices. So our expression is simply the item itself. So basically, we'll iterate over the list of items. We'll get each item and simply return it. However, we want to filter them. So we'll add an if statement if item of 1 is greater than or equal to 10. Once again, I personally find what we have on line 11 more readable and cleaner than what we have on line 10. But if you want to use the map or filter functions, that's perfectly fine. Here we have two lists. Let's say we want to combine these two lists into a single list of tuples like this. So we have a list where each item is a tuple. And in the first tuple, we're going to have the first element of each list. So 1 and 10. Similarly, in the second tuple, we're going to have the second element of each list. And finally, the third tuple. How can we combine these two lists into a single list like this? Well, in this case, we can use the map function or a list comprehension because both these work with a single list. But here we're combining multiple lists. To achieve this, we use the built-in zip function. So zip, look, this function takes multiple iterables and it will combine them the way I showed you. So we pass list 1 and list 2. Let's print the result on the terminal. So look, it returns a zip object, which is also iterable. So we can iterate over it or simply pass it to the built-in list function to convert it to a list. Now let me show you something cool. As you saw, this zip function takes one or more iterables. So we don't have to pass a list here. I can also pass a string like ABC and look at the result. So now our string ABC is spread across multiple tuples in this list. That's pretty powerful. If you want to achieve the same thing in other programming languages, you have to write several lines of code. But in Python, you can do it in a single line. In programming, we have a common data structure called stack, which resembles a stack of items in the real world. Imagine you have a stack of books. The last book that you put on top of this stack is the first book that you can remove. You refer to this behavior as LIFO, which is short for last in, first out. So this is a stack data structure, and it's very common in real-world applications. A good example of that is your browser. Whenever you navigate to a new website, your browser keeps your browsing session in a stack, so when you click the back button, it takes you to the previous website. Let me show you how it works. So we start with an empty stack. Now let's say we navigate to website number 1. Now here for simplicity, I'm using a number. If you're building a browser, instead of a number, we'll use a string, which is the address of the current website. Now let's say we navigate to a couple more websites and then click the back button. At this point, the browser removes the item on top of the stack, and then it will redirect us to the previous website. Now let's say we press the back button a couple more times, so we'll end up with an empty stack. At this point, the browser will disable the back button. This is how a stack works. Last in, first out. Now let me show you how to use a stack in Python. Basically, we can use a list object as a stack. So here I'm going to define a variable like browsing session and set it to an empty list. Now let's say the user navigates to website number 1. So we call browsing session.append method and add the address of the current website. Now let's say the user navigates to website number 2 and then 3. Let's have a look at what we have in our stack. So we print it, and as you see, we have a list of 3 items. Now, when the user presses the back button, we should remove the last item in this list, right? How do we do it? We use the pop method. So we call browsing session.pop. This will remove the last item from the stack and return it. So we can get it here. But in this case, we're not going to use this value. Let me just print it on the terminal. So you can see that. So 3 is removed from the stack. Now, if we print our stack one more time, print browsing session, you can see 3 is removed and we have only 2 items in our stack. So we need to take the user to the previous website, which is the item on top of the stack. And we can get that using a -1 index. Very easy. So back here, browsing session of -1. This returns the last item. So we print it. And I would like to add just a label for clarity, redirect. Let's look at the result. So when the user presses the back button, we redirect them to the previous website, which is website number 2. Now here we need to check if the stack is empty or not. If it becomes empty, we need to disable the back button. So that is very easy. Earlier in the course, I told you about the falsy values. So number 0, an empty string, an empty list, these are all falsy values. So if we apply the not operator to an empty list, we'll get the Boolean true. So to see if our stack is empty, we can simply write code like this. If not browsing session, then at this point, we will disable the back button. So let me recap. We use the append method to add an item on top of the stack. We use pop to remove the item on top of the stack. We use index -1 to get the item on top of the stack. And of course, before doing that, we need to check to see if our stack is empty or not, because if it's empty, when we run this code, we'll get an error. So if not browsing session, then we'll get the item on top of the stack. These are the operations that you can perform on stacks. In the last lecture, you learned about stacks. You learned that stacks have the LIFO behavior, last in, first out. We have another very useful data structure called queue, which has the FIFO behavior, first in, first out, and it resembles a queue in the real world. Let's say a queue of people to get into a restaurant. The first person in the queue is the first person who would get in. Now, technically, you can use a list to implement a queue in Python. So let's say we have a queue of 3 items. If we want to remove an item from this queue, we should remove the one at the beginning as opposed to the one at the end. So we remove 1, and then 2, and then 3. However, if you're dealing with a large list or a large queue, you might see some adverse effect on the performance. Because let's say we have a large number of items in this list. Every time we remove an item from the beginning of this list, all the other items need to be shifted to the left. So if you have a list with 1,001 items, when you remove one item, 1,000 items need to be moved in memory. In situations like that, it's more efficient to use a dequeue object. Let me show you how to do that. So first, we need to import dequeue from the collections module. I'm going to talk about modules later in the course. For now, let's imagine a module is a bucket with a bunch of reusable code. So from collections, that's the name of our module, we should import dequeue, which is a class. Again, I'm going to talk about classes later in the course. So we import a dequeue class here. Now, instead of defining a variable and setting it to an empty list, we should wrap this list with a dequeue object. So we call dequeue and pass our empty list as an argument. This dequeue object has similar methods that we have in the list object. So we can call queue.append. Let's append a few items here, 1, 2, 3. Now to remove an item from the beginning of the queue, we call queue.popleft. We don't have this method in list objects. So after we remove one item, let's look at our queue. There you go. You can see 1 is removed, and now we only have 2 and 3. Also, similar to lists, we can easily check to see if a queue is empty using the not operator. So if not queue, that means we have an empty queue. Then we can print something like empty. So this is all about queues. Throughout the course, I've mentioned tuples a few times. In this lecture, we're going to take a closer look at them. A tuple is basically a read-only list. We can use it to contain a sequence of objects, but we cannot modify this sequence. We cannot add a new object to it, we cannot remove an existing object, and we cannot modify an existing object. So let's start by defining a tuple called point. Instead of square brackets, we use parentheses to define a tuple. So here we add a couple of numbers here, a point with x and y values. We can also exclude parentheses, and Python will see this as a tuple. Let me show you. So let's print type of point and run this program so you can see it's a class of tuple. Now, if you have one item, you should add a trailing comma. Otherwise, Python thinks you're defining an integer. So if we run this code, you can see point is an integer, but if we add a trailing comma here, Python treats this as a tuple. Also, if you want to define an empty tuple, you should use empty parentheses. So let's run this one more time. You can see point is still a tuple. Now, similar to lists, we can concatenate two tuples. So here we have one tuple. We can concatenate it with another tuple. Let's print the result. So now we have this tuple with numbers 1 to 4. We can also use the multiplication operator to repeat a tuple. So now when we run this code, we have a tuple with 1, 2, 1, 2, and 1, 2. These are different ways to create a tuple. You can also convert a list to a tuple. So let's say we have a list of 2 numbers. To convert this list to a tuple, we call the tuple function. As you can see, this function takes an iterable. So we can pass any iterables here, and this function will return a tuple. So here's one example. Let's print point. Now we have a tuple of 2 numbers, or we can pass a string like hello world. And because strings are iterable, now we get a tuple of 11 strings. Now let me revert this back to a simple tuple. Similar to lists, we can access individual items using an index. So we can get the first item, which is 1, or we can get a range of items like items from index 0 to index 2. This returns another tuple with only those objects. We can also unpack these tuples. So we can define 3 variables like x, y, and z and set it to point. Similar to lists, we can use the in operator to check for the existence of an item. So if 10 is in point, then we print exists. But as I told you, these tuples are immutable. We cannot mutate them. We cannot change them. So if I try to modify point of 0 and set it to a new number, look, we immediately get this red underline. And if we run the code, we get this type error. Tuple object does not support item assignment. For this very reason, unlike lists, we don't have methods to add a new object or remove an existing object. So you might ask, where in the real world we use tuples? Here's a basic rule of thumb. Let's say you're dealing with a sequence of objects, and you want to make sure that you don't accidentally modify this sequence, you don't accidentally add a new object to it or remove an existing object. So instead of a list, you can use a tuple to prevent these accidental errors. Now let me show you something really cool. I'm going to define 2 variables, x and y. A basic exercise we give to people who start in programming is to write code to swap 2 variables. Do you know how to do this? If you don't, pause the video and think about it for a minute. But here's the solution. To swap 2 variables, we need a third variable. So I'm going to define a third variable like z and set it to x. So basically, we're copying the value of x into a separate variable as a backup. Now we can overwrite x with y. So we set x to y. We copy the value of y to x. Now we have the old value of x stored in z. So we can use that to overwrite y. We set y to z. With these 3 lines, we can swap the value of these 2 variables. So if we print x as well as y, we will see that x is changed to 11 and y is 10. Now I've got a good news for you. In Python, we can swap the value of 2 variables using only 1 line of code and without a third variable. Let me show you. So instead of writing these 3 lines, we can simply write x, comma y equals y, comma x. Now, if we run this code, we get the exact same result, but let me explain what exactly happens under the hood. Here on line 4, on the right side of the assignment operator, we're defining a tuple. Because in the last lecture, I told you that when defining a tuple, you can use parentheses or you can exclude the parentheses. So this code is exactly equivalent to this. We have a tuple. What is y? It's 11. What is x? It's 10. Now, what do we have on line 5? We have a tuple that we're unpacking. So we are setting x to 11 and y to 10. And that is why, with this line of code, we can easily swap 2 variables. For this very reason, we can define multiple variables on the same line. So we can define a and b and set them to 1 and 2. Once again, we're defining a tuple and then unpacking it on the left side. So A will be 1 and B will be 2. So you have learned a lot about lists in Python. These lists are very useful, but if you're dealing with a large sequence of numbers, we have a more efficient data type in Python called array. These arrays take less memory and perform a little bit faster. But note that you will see the difference only if you're dealing with a large list of numbers, let's say 10,000 or more. So for 90% of the cases, you will use lists. But if you run your program and you see some performance problems, then you can see if you can solve the problem by replacing a list with an array. If you don't have any performance problems, don't try to optimize. In other words, don't solve a problem that doesn't exist. So let me show you how to use arrays in Python. To use an array, we need to import it from the array module. So on the top, from array, import array. So we have a module called array, and in this module, we have a class called array. It has the same name as the module itself. Now, we call array. Look at the first parameter. This is called a type code, which is a string that determines the type of objects in your array. So here in Google, search for Python 3 type code. Then click the first link. In this table, you can see all the type codes in Python. So it's a string of one character that determines the type of objects in your lists. So if you're dealing with signed integers, you should use a lowercase I. So here, let's add I. And then as a second argument, we pass a list of integers. So we move this list here. Now we get an array. We can call it numbers. In this object, similar to lists, we have methods for adding new objects or removing existing ones. So we can call numbers.append to append a number to the end of the list, or we can use insert to add a number at a specific index. We also have pop and remove exactly like lists. And we can also access items by their index. So we can get the first item in this array. However, unlike lists, the objects in this array are typed. So here, every object should be an integer. If we try to put a floating point number here or any other kind of objects, we'll get an error. Let me show you. So I'm going to change the first item to 1.0. Now let's run the program. We get this type error, integer argument expected, got float. So every object in this array should be of the same type, which is determined at the time of creating the array using the type code. So to recap, use arrays only if you're dealing with a large sequence of numbers and you encounter performance problems. For other cases, use lists and tuples by default. In Python, we have another very useful data structure called a set, which is basically a collection with no duplicates. So let's say we have a list of numbers with a bunch of duplicate items like this. If you want to remove the duplicates, you can convert this list to a set. So I'm going to define a variable Unix. We call the set function and pass the numbers list. Now, when we print this, take a look. We only have unique items, so one is not repeated. Also note that we use curly braces to define sets. So here we can define a second set using curly braces with two items, 1 and 4. Now, similar to lists, we can add new items to a set or remove an existing one. So here we can call second.add. We can append a new number here. We can also call remove. And we can use the len function to get the number of items in a set. So these are the basics. But where sets shine are in the powerful mathematical operations that are supported by them. Let me show you. So I'm going to delete these 3 lines. These are pretty basic. And rename Unix to first. So we have 2 sets, first and second. Now, we can get a union of 2 sets using the vertical bar. So this expression will return a new set that includes all the items that are either in the first or in the second set. Let me show you. So print. Actually, I'm going to change this 4 to 5. So now when we run this code, you can see the union of these 2 sets is another set that includes all the items that are either in the first set or the second set. We can also get the intersection of 2 sets. So print first and second. This will return a new set that includes all the items that are in both first and second sets. Take a look. So the only number that exists in both these sets is 1. We can also get the difference between 2 sets. So print first minus second. when we run this code, we get 2, 3, 4. So the first set has these additional numbers that we don't have in the second set. And finally, we have symmetric difference. So print first, caret second. This will return the items that are either in the first or second sets, but not both. So let's run this. We get 2, 3, 4, 5. Now, one thing you need to know about sets is that unlike lists, they're unordered collection, which means the items that we have in a set are not in sequence, so we cannot access them using an index. In other words, if we try to print first of 0, we will get a runtime error. Set object does not support indexing. So if you need to access items by an index, you need to use a list. With sets, quite often we use one of these operations here, or we can check for the existence of an item in a set. So we can check to see if 1 is in the first set, then we can print yes. There you go. So to recap, set is an unordered collection of unique items. We cannot have duplicates, and these objects are unordered. They're not in sequence. So we cannot access them using an index. In Python, we have a very powerful data structure called dictionary that is basically a collection of key value pairs. We use it to map a key to a value. A real-world example of this is a phone book. In a phone book, we map a person's name to their contact details. So we use a person's name as the key and their contact information as the value. So a phone book is a dictionary. It's a collection of key value pairs. Now let me show you how to work with dictionaries in Python. So I'm going to define a variable, point. We can set it to an empty dictionary, or we can add one or more key value pairs here. Here's an example. We set x to 1 and y to 2. So in this example, I'm using a string for the key and an integer for the value. In Python, we can only use immutable types for the keys, so quite often we use strings and numbers. But the value can be of any type. There are no limitations. So here's one way to define a dictionary. We can also use the dict function. Just like we have the list, tuple, and set functions, we also have the dict functions that we can use to create a dictionary. So let me redefine point by calling the dict function. So when we call this function, we pass one or more keyword arguments. Remember keyword arguments? So x equals 1. This is a keyword argument. We can also set y to 2. Now, I personally prefer the second approach because we don't have to deal with these quotes. I find this syntax a little bit cleaner and shorter. So now we have a dictionary. We can get the value associated with a key using an index. So point of x. Note that our index is the name of a key. So because dictionaries are collections of key value pairs, we cannot access an item using a numeric index as we do with lists. So here we're getting the value associated with the key x. Let's print it on the terminal. So we get 1. Similarly, we can change the value of x to a new value. Now let's print our dictionary. So x is 10, y is 2, beautiful. We can add a new key. So let's set z to 20 and then print the point. So now we have 3 key value pairs. Now, when reading a value, if we use an invalid key, we'll get an error. So let's look up the value of the item with the key A and then print this, run the program. We get this error, key error. There are 2 workarounds here. One solution is to check for the existence of a key. So if A in point, then we'll get the value of the item with key A and print it. Now, we don't get the error anymore. The other solution is to use the get method. So instead of using brackets and the name of the key, we call the get method. Here we pass the name of the key. Let's print it. So if the key doesn't exist, by default, it returns none. Or we can pass a default value as a second argument. So we say, hey, if you don't have an item with the key A, return 0 by default. Let's take a look. Now we get 0. Beautiful. To delete an item, we use the del or delete statement. So delete point of X. Now let's print point and look at the result. So X is gone. We only have Y and Z. So these are the basic operations around dictionaries. We can easily add new items, remove existing ones, and look up items by their key. Finally, let me show you how to loop over dictionaries. So if we write a simple for statement for X in point, let's see what we get. We get Y and Z. So in each iteration, our loop variable will hold the key of an item. So it's better to rename this to key. Now we can print the key as well as the value associated with the key. So we write point of key. As you can see, Y is 2 and Z is 20. There is another way to iterate over a dictionary. So here we can call point.items. Now let me rename key to X and just print X. Let's see what we get. So in each iteration, we get a tuple. In this tuple, we have the key and the value. So we can unpack it right here. We can extract key and value and simply print them here, like this. When we run the program, we get the same result. All right, look at this piece of code here. On the top, we're defining an empty list. Then we're iterating over this range object. In each iteration, we get X, multiplied by 2, and add it to our list. As I told you before, whenever you have this pattern in your code, you can either use the map function or preferably a list comprehension. So let's review the syntax for a list comprehension. We have square brackets to define a list. And here's our comprehension expression. We have expression for item in items. So we iterate over an iterable. In each iteration, we get this item and then do something with it. So what is our iterable in this example? It's this range object that is returned from the range function. So range of 5 here. What is our loop variable? That is X. And what is our expression? We're multiplying X by 2. So we can store the result in values. This line of code is exactly identical to these 3 lines. So let's delete this. Now, these comprehensions are not limited to lists. We can also use them with sets and dictionaries. So now, if we replace these square brackets with curly braces, we get a set. Let's print values. So we get a set of even numbers, right? Now, what is the syntactical difference between a set and a dictionary? Well, for both these data structures, we use curly braces. In sets, we just have values, but in dictionaries, we have key value pairs that are separated using a colon. So here we can map 1 to a character, 2 to another character, and so on. So we can easily use comprehension expressions to create dictionary objects. So here in this expression, all we need to do is to change this expression such that we have a key value pair. So here we can use X as the key and X times 2 as the value. Now let's delete these 2 lines, save the changes, and run the code. We have this dictionary with these key value pairs, okay? So instead of defining an empty dictionary, then looping over an iterable, and then in each iteration, adding something to this dictionary, like values of X equals X times 2, whenever you have this pattern in your code, you can use a dictionary comprehension. So to recap, we can use comprehensions with lists, sets, and dictionaries. But what about tuples? Let's take a look. So let's remove this key value pair and only use X times 2, and also change the curly braces to parentheses. Let's also delete these few lines. Run the program. We don't get a tuple. What's going on here? We get a generator object. And that's the topic for the next lecture. Here we're creating a list using a list comprehension expression. Then we iterate over all the numbers in this list and print them. When we run this program, we get the even numbers from 0 to 18. This is perfectly fine, but there are situations that you might be working with a really large data set, or perhaps an infinite stream of data. In those situations, you shouldn't store all those values in the memory, because that's very memory inefficient. For example, what if instead of range of 10 here, we had the range of, let's say, a billion? We don't want to store a billion objects in memory. That takes too much memory. In situations like this, it's more efficient to use a generator object. Generator objects are iterable, so just like lists, we can iterate over them. And in each iteration, they generate or spit out a new value. So unlike lists, they don't store all the values in memory. They generate a new value in each iteration. Let me show you how that works. So here, I'm going to replace these square brackets with parentheses. Save the changes, run the program. We get the exact same result. However, values is no longer a list. It's a generator object. Let me show you. So print values, run the program, we get a generator object. So as you can see, generator objects are iterable. We can iterate over them. In each iteration, they spit out a new value. But what is interesting is the size of generator objects. Let me show you how you can get the size of an object. So on the top, from the sys module, we should import a function called getSizeOf. So here we have a generator object. Let's change range to 1,000. Now let's print the size of this object. So I'm going to delete everything here. Call getSizeOf function, pass our generator object, and then print the result. Let's also add a label here. So generator. Run the program. So our generator object takes 120 bytes of memory. What if we change the range to 100,000? Let's run the program. The size of this generator object remains consistent. In contrast, if we used a list comprehension expression here, we would end up with a list of 100,000 items. Let me show you. So I'm going to copy this line and then duplicate it and change parentheses to square brackets. So now we have a list. Let's copy this line as well, change the label, and see the size of this list. Run the program. So our list is taking over 800,000 bytes of memory compared to our generator object that takes only 120 bytes. So in situations where you're dealing with a really large data set or potentially an infinite stream of data, use a generator expression to create a generator object. So when we use parentheses around a comprehension expression, just be aware that because generator objects don't store all the items in memory, you won't be able to get the total number of items you're working with. For example, here, let's just keep the generator object and then print the len of values. When we run this code, we'll get an error. Let's take a look. Object of type generator has no len because we can only access these items, these values, when we iterate over a generator object. So we won't know ahead of time how many objects or how many items this generator is going to produce. So in this section, you have learned a lot about data structures in Python. One operator that comes handy when working with these data structures is the unpacking operator. Let me show you how that works. So let's say we have a list of numbers, 1, 2, 3. If we print this list, we get a list on the terminal. But what if you want to print the individual numbers? In other words, what if we want to get an output like this? Let's run this program. So here we don't have square brackets and we don't have comma. We're printing out individual numbers, individual items in our list. To achieve this, we can use the unpacking operator. So all we have to do is prefix this variable with the unpacking operator. In JavaScript, we have an operator called spread operator, which is 3 dots. This is exactly the same. So here we unpack a container, take out its individual elements, and pass them as arbitrary arguments to the print function. Now, if we run this program, we get the exact same output. Another useful application of this is when creating lists. So let's say we want to have the list of numbers from 0 to 5. You know that this range function returns a range object, so we need to convert it to a list and then store the result in this variable. Now let's print this. We get 0 to 4, beautiful. In this case, instead of calling the list function, we can use the unpacking operator. So we call range of 5. This returns an iterable, right? The good thing about this unpacking operator is that we can unpack any iterables. It doesn't have to be a list. So we unpack this iterable, which basically means we take individual values, then we put them in a list, and finally store the result here. By the same token, we can unpack a string. So we unpack a string like hello. Now let's take a look at the result. So we have the numbers 0 to 4. Now because we're unpacking this hello string, we're getting individual characters and put them in our list. So these are some cool tricks that we can do in Python that, as far as I know, we don't have in other popular languages. Let's look at another example. Using this operator, we can combine multiple lists. So here we can have one list and another list. Now, to combine these lists, we can unpack the first one and then the second one. We can also put something in the middle or unpack a string at the end, hello. So it's very powerful. Now we can also unpack dictionaries, but we need to use 2 asterisks. Let me show you. So I'm going to define one dictionary. Let's add a key value pair here. So X. Now let's define the second dictionary. I'm going to repeat X here, but with a different value, and also add Y. Now, to combine these dictionaries, we can use the unpacking operator. So we create an empty dictionary. We unpack the first dictionary. This will take out all the key value pairs in our first dictionary. And then we'll unpack the second dictionary. We can additionally add another key value pair. Now, let's print the result. Note that the value of X is 10. So if you have multiple items with the same key, the last value will be used. So to recap, we can use the unpacking operator to take out individual values in any iterable.